Oh yeah, I'll be the first to tell you. Okay, yeah. Thanks for turning it around.
Oh, really?
I would never. I'd tell you what.
All right, well, that's good.
It's like this one.
Slightly different angle going on right now. You press record. Oh yeah, there's one. That one's different. Now what am I looking for? Is it gonna blink me again?
Oh, the tape's in my pocket.
Excellent. I'm always wondering where my cell phone is when I'm on the phone.
I think I thought it was my cell phone. Is that, wait,
Yeah.
my cell phone's there. What's this? The chalk's there. What's this?
Don't put chalk in your pocket. We know you like chalk, but don't put it in your pocket.
I want this to be on one book. There's a picture.
Smart people can be forgetful.
So if instead of treating the epoxide with water under acidic conditions, right, you made a hydroxide anion instead. As with sodium hydroxide. Then what did we learn from workshop? Would be the most likely thing to occur here. Attack on which side?
Our right.
The least hindered side, right? So this would give you preferential attack on the least hindered because this reaction is now SN2-like. So as an intermediate, you would have the O minus that you formed there, and the OH from the hydroxide anti to each other in the product. So it's still anti-stereochemistry in that respect. But at this stage of the game, you would have made an alkoxide. So if what you want is to make this antidiol, you would have to do first step reaction with NaOH, second step addition of aqueous acid. So here now you're adding dilute aqueous acid, just enough to adjust the pH. It's not like you're adding concentrated sulfuric acid again. Okay. But the acid would just serve to protonate that alkoxide. So you end up with an anti-diol again. Okay? Now, if you're just doing a diol, you can't really, you can't really tell which OH added first, which one came from your original epoxide, and which one was the one that you added from the sodium hydroxide, right? But mechanistically, you know that this is the way it should go. So if we do something a little different, let's say we treat that epoxide with some, treat that epoxide with sodium methoxide, which is going to be a source of OCH3 minus anions. Then again, we're going to attack the less substituted side, right? But it again has to attack from the opposite face to where the epoxide oxygen is pointing. So this must attack from on top, pushing that back. So after acidification, what you end up with would be that. So then, you would have to make your alkoxide first. If you started off with an alcohol, you'd have to think about the sequence with which you add things together in order to get the product that you're looking for. So don't forget now, in this anionic or nucleophilic ring opening, the anion that you use could also be something like a Grignard reagent or an organolithium reagent. So let's see. So if we treat this epoxide with phenyl magnesium bromide as our Grignard reagent, the Grignard reagent acts as an anion, so it's going to attack the less substituted side. So what we would end up with there after acidification would be